Buckle up, it's space time. Number 10, Saturn's screaming auroras. In April 2002, engineers monitoring NASA's Cassini spacecraft picked up something unexpected. The probe was still 234 million miles from Saturn, and yet its radio and plasma wave science instrument was already detecting powerful structured radio emissions pulsing outward from the ringed planet. When scientists at the University of Iowa shifted those emissions into the human hearing range, the results sounded disturbingly like a spinning air raid siren, cycling and wailing from a world we had barely begun to approach. Saturn kilometric radiation, or SKR, had been theorized before Cassini arrived. Scientists expected to find radio emissions tied to Saturn's auroras, much like the emissions detected around Earth. The working assumption was straightforward. The signals would pulse in rhythm with the planet's rotation, giving researchers a precise way to measure how fast Saturn spins, just as similar measurements had worked cleanly at Jupiter. What they found instead was deeply puzzling. The north and south poles of Saturn were broadcasting at measurably different rotational periods, as if the two hemispheres existed in slightly different versions of time. The emissions were not fixed. Over the years of Cassini's mission, the rates shifted, drifted, and even swapped dominance as Saturn moved through its seasons. No single theory has fully explained the mechanism driving this asymmetry. According to University of Iowa physicist William Kurth, deputy principal investigator for the RPWS instrument, scientists confirmed the changing frequencies were related to tiny radio sources moving along Saturn's magnetic field lines near the auroral regions. But despite years of close observation, including Cassini's eventual flight directly through the source region before its 2017 mission end, the underlying cause of the hemispheric difference remains contested. Saturn's own poles cannot agree on what time it is, and after decades of listening, neither can the scientists trying to explain them. Number 9. The black hole that shouldn't be able to speak. In 2003, astronomer Andrew Fabian of Cambridge University was analyzing X-ray data from NASA's Chandra X-ray Observatory when he noticed something astonishing embedded in images of the Perseus Galaxy Cluster, located approximately 250 million light-years from Earth. Rippling outward through the superheated gas surrounding a supermassive black hole were pressure waves, vast and ancient, propagating through the cluster's intracluster medium in a pattern that could only mean one thing. The black hole was generating something functionally equivalent to sound. Sound, in the traditional sense, cannot exist in the vacuum of space. There are no molecules to compress and rarefy, no medium to carry a wave from one point to another. This is the foundational rule of acoustics in the cosmos. But the Perseus cluster contains an enormous reservoir of hot plasma, an intracluster medium dense enough to transmit pressure waves across millions of light years, making it one of the few environments in the universe where something genuinely analogous to acoustic propagation can occur. In May 2022, NASA converted those pressure waves into audible sound and released the recording publicly. The result stopped people in their tracks, shifted upward by 57 octaves from their true frequency, which sits far below the threshold of human hearing. The black hole produced a deep, resonant groan that many listeners compared to a voice. The structure generating this sound spans approximately 11 million light-years across. The science behind the waves is understood in broad terms. The black hole periodically consumes matter, and the resulting outbursts drive pressure waves outward through the plasma. But the precise mechanics of how those bursts are timed, sustained, and structured continue to generate new research questions with each new Chandra observation. That black hole has been holding the same note without pause for longer than our planet has existed, and we only learned to hear it in 2022. Number 8. The hum at the edge of everything. On May 10, 2021, Cornell University doctoral student Stella Koch-Acker published findings in the journal Nature Astronomy that changed what scientists thought they knew about the space between stars. Analyzing data transmitted from Voyager 1, humanity's most distant object, traveling more than 14 billion miles from Earth, Acker had identified something that no model of the interstellar medium had predicted: a faint, persistent, continuous hum emanating from the void between star systems. Voyager 1 crossed into true interstellar space in 2012, passing through the heliopause, where the sun's influence finally fades. Scientists expected the craft to find a relatively calm, structurally passive environment. The interstellar medium was thought to be largely featureless between the solar shock waves that occasionally ripple through it. Researchers had only been able to take intermittent measurements of plasma density during those energetic events, not between them. What Ocker found was that Voyager's plasma wave system was detecting a weak narrowband plasma wave emission persisting continuously from 2017 onward, unconnected to any solar event. The hum is described in the paper as quasi-monochromatic, remarkably consistent in frequency, like a single sustained tone held indefinitely in the dark. The emission allowed researchers to track interstellar plasma density in near real time, something previously considered impossible without a triggering event. Cornell research scientist Shami Chatterjee noted the significance immediately. The craft was now reporting plasma density continuously, without waiting for the sun to send a disturbance outward. The possible mechanisms driving the emission, including thermally excited plasma oscillations, remain under investigation, and no definitive explanation has been confirmed. The void between stars was supposed to be silent. Instead, it is humming with something we cannot yet explain, a tone that has apparently been playing undetected through all the years we were listening for other things. Number 7. Mars is moaning. On April 6th, 2019 at 0226 UTC, the seismometer aboard NASA's InSight lander registered a faint trembling beneath the surface of Mars. Scientists at the French space agency CNES, which built the SEIS instrument, confirmed what they had been waiting months for, the first Marsquake. The detection was historic, but the character of what InSight recorded over the following 3 years, including sounds that when played back resembled a low rhythmic moaning unlike anything in Earth's seismic catalog, proved far stranger than anyone had anticipated. InSight touched down on November 26, 2018, in the Elysium Planitia region of Mars. The mission's core goal was to probe the deep interior of a world scientists had long classified as geologically dormant. Mars has no tectonic plates grinding against each other, no confirmed active volcanism visible at the surface. The expectation was that Marsquakes, if detected at all, would be infrequent and faint. Gentle tremors from a world that had largely gone quiet billions of years ago. By the time NASA declared the InSight mission complete in December 2022, the lander had detected more than 1,300 Marsquakes. Some were minor. Others were substantial, including a magnitude 5 event in May 2022 that exceeded all expectations. More unsettling was the persistent low-frequency hum the planet emitted between quakes, a continuous tonal signal whose source remains debated among planetary scientists. Marsquake audio, shifted into the human hearing range, carries an eerie tonal quality that Earth seismic data simply does not produce. The Martian interior is revealing a complexity that existing models of the planet's geology struggle to accommodate. The composition of its core, the layering of its crust, and the mechanism sustaining its seismic activity all contain anomalies that post-mission analysis is still working through. If a planet we declare geologically dead is still moaning beneath the surface, it raises an uncomfortable question about how many other worlds we have wrongly assumed were silent. Number 6. The music no one was supposed to hear. In May 1969, the 3-man crew of Apollo 10 were the farthest humans from Earth in history, approximately 220,000 nautical miles out, conducting the final rehearsal before the moon landing. Commander Thomas Stafford, Command Module Pilot John Young, and Lunar Module Pilot Eugene Cernan were orbiting the far side of the moon, completely cut off from any radio contact with Earth, when something began playing through their headsets. Cernan's voice, preserved on tape, captured the moment precisely. You hear that? That whistling sound? Sounds like, outer space-type music. The sounds continued for approximately an hour, cycling and rising while the crew orbited behind the moon, in total communication blackout. The 3 astronauts were among the most technically trained humans alive, intimately familiar with every mechanical and electronic sound their spacecraft produced. They discussed the phenomenon at length, uncertain whether to report it to mission control when contact resumed. One concern surfaced clearly in the recording. If they mentioned it, it might ground them from future missions. The most widely accepted explanation is radio frequency interference between the VHF systems of the command module and the lunar module, which were running in close proximity during the orbital separation phase. Apollo 11 pilot Michael Collins, warned about the phenomenon before his own missions, described exactly this kind of interference in his memoir. But Apollo 15 astronaut Al Worden, reviewing the recordings decades later, disagreed with the radio interference explanation entirely, arguing that experienced crew would not have been confused by familiar equipment noise. Here's what makes the mystery genuine rather than manufactured. The moon has no atmosphere and no significant magnetic field. The charged particle interference that produced similar effects at Saturn, as documented by Cassini, requires exactly those conditions. Neither existed at the moon in 1969. The transcripts were available in the National Archives from 1973 onward, but the audio sat largely unnoticed for decades. A quiet record of 3 astronauts hearing something they could not explain, and choosing for entirely human reasons to say nothing. Number 5. Earth is roaring. In August 2012, NASA launched 2 spacecraft into Earth's radiation belts aboard a single rocket. The mission was called the Van Allen probes, and its instruments were designed to study the 2 enormous rings of high-energy particles that encircle our planet. Within months of entering orbit, the probe's instruments began returning something that made researchers at the University of Minnesota and beyond stop and listen more carefully. Earth, it turned out, had been roaring for billions of years. We simply had not had the right ears to hear it. The phenomenon is called very low-frequency chorus waves, and it originates in the Van Allen radiation belts approximately 15,000 miles above the planet's surface. Unlike the electromagnetic emissions from other planets, which require significant frequency shifting to fall within human hearing range, chorus waves naturally occur between 0.1 and 10 kilohertz, placing them directly within the range of human hearing. Scientists named them chorus, because the converted audio sounds strikingly like a dawn chorus of birds, an ascending melodic shimmer rising out of the magnetosphere. What makes the phenomenon unsettling is not the sound itself, but its consequences. These waves are energetic enough to accelerate electrons within the radiation belts to velocities approaching the speed of light. Those electrons, known informally as killer electrons, can penetrate and permanently damage satellites, threaten astronauts, and disrupt technology across the planet. The chorus waves are not passive. They are the engine driving some of the most hazardous space weather events that affect human civilization. Ground-based researchers first detected hints of chorus waves in the 1950s, but the Van Allen probes provided the first comprehensive, high-resolution recordings, revealing a structure and melodic complexity far beyond what early observations suggested. Our own planet has been generating this electromagnetic roar since before the first organism drew breath, completely surrounding every human who ever lived, and we spent nearly all of human history completely unaware of it. Number 4. Jupiter's howl at the edge of its own kingdom. On June 24, 2016, NASA's Juno spacecraft crossed a boundary that no probe had measured from the inside with such precision. The bow shock of Jupiter's magnetosphere, the point where the planet's enormous magnetic field collides head-on with the solar wind streaming outward from the sun. As the spacecraft passed through that boundary, its WAVES instrument, developed by University of Iowa physicist William Kurth, captured the transition in stunning detail. The resulting audio recording, released by NASA, begins as a wall of chaotic noise and then, in the span of seconds, collapses into something structured, almost orchestral. Jupiter was announcing itself. Jupiter's magnetosphere is the largest structure in the solar system, excluding the Sun's own heliosphere. If it were visible to the naked eye from Earth, it would appear approximately twice the diameter of the full moon in the night sky. Scientists understood in general terms what Juno would encounter, but the electromagnetic complexity that the WAVES instrument recorded at the bow shock exceeded the predictions of even the most detailed pre-mission models. Beyond the bow shock crossing, Juno documented Jupiter's whistlers, lightning-generated electromagnetic waves that travel along magnetic field lines and produce a descending whistling tone when converted to audio. The lightning generating these waves is ferocious. During Juno's first 8 months in orbit, the spacecraft's instruments registered approximately 1,600 lightning signals. Some individual Jovian lightning events are estimated to be several times more energetic than their terrestrial equivalents. What unsettles planetary scientists is the structural organization of what Juno recorded. The electromagnetic emissions display a complexity, from organized whistlers to the sharp tonal shift at the bow shock, that suggests Jupiter's magnetic environment behaves more like a dynamic responsive system than a simple passive field. Jupiter has been conducting this electromagnetic symphony for 4.5 billion years, and we arrived just in time to hear the overture. Number 3. The sun has been screaming since before Earth existed. In the early 1960s, physicist Robert Layton at the California Institute of Technology noticed something peculiar in observations of the sun's surface. The photosphere, the visible outer layer of the star, was oscillating rhythmically, rising and falling by miles on a remarkably consistent 5-minute cycle. Further theoretical work by Roger Ulrich in 1970 confirmed what this meant. Pressure waves were bouncing through the solar interior, and the sun was, in the most physically precise sense of the word, ringing. The field that grew from this discovery, helioseismology, would eventually give humanity its only window into the hidden interior of the star that created us. NASA's Solar and Heliospheric Observatory, launched in 1995 as a joint project with the European Space Agency, has provided the most detailed continuous data on solar oscillations ever collected. The sun's acoustic modes, known as P modes, carry information about density, temperature, and composition across layers that no instrument will ever directly penetrate. In 2018, researchers at the University of Sheffield converted 3 months of solar data into a 40-hour audio file, collapsing the oscillations into the range of human hearing. The result is a deep, layered, overwhelming sound that has been playing without interruption since before our planet formed. The scientific significance runs deeper than the strangeness of the sound itself. The patterns within the oscillations reveal the sun's internal structure with a precision that no other observational technique can match. Yet those same patterns occasionally diverge from what our best stellar models predict, suggesting that our understanding of the sun's interior, the nuclear furnace responsible for all life on this planet, remains incomplete. The frequency of the oscillations puts the sun's true sound approximately 10 million times below the threshold of human hearing. It has never been silent, it has never paused. Across 4.6 billion years of continuous output, the star responsible for every living thing on Earth has been broadcasting its internal complexity in a language we only recently learned to decode. The star that made us has been trying to tell us something about its own hidden depths for longer than Earth has existed. And even now, with the most sophisticated instruments ever built, we are still working out what it means. Number 2. The sound wave that crossed the edge of the universe. In 2014, Don Gurnett, professor of physics at the University of Iowa and principal investigator of Voyager 1's plasma wave science instrument, presented data at the American Geophysical Union meeting that redefined what scientists thought the space between stars was capable of producing. A coronal mass ejection from the sun, launched months earlier, had traveled across the entire span of the heliosphere and beyond, plowing into the interstellar medium and generating a shock wave large enough for Voyager 1 to detect in real time. The plasma wave instrument converted the resulting vibrations to audio. What played back sounded, with unnerving precision, like something enormous approaching through the dark. Voyager 1 was launched on September 5th, 1977, before the personal computer existed, running on technology that delivers approximately 4 watts of power to its science instruments today, less than the energy required to light a small incandescent bulb. It crossed into true interstellar space in 2012. The plasma wave instrument it carries was designed to detect oscillations in charged particles, and it was that same instrument that captured what researchers described as a tsunami wave, the solar shock wave making the interstellar gas vibrate, in Gurnett's own words, like a ringing bell. Voyager experienced its first such tsunami in October 2012, a second in April 2013, and a third beginning in early 2014 that was still propagating outward 9 months later, during which time the spacecraft moved 250 million miles further into interstellar space. Each event revealed that the medium between stars was far more dynamic and structured than the smooth, quiet environment scientists had assumed it would be. Then, in 2021, Cornell researcher Stella Koch-Acker published evidence that even between those dramatic shockwaves, the interstellar medium was humming persistently, a revelation that further dismantled the old picture of intergalactic silence. Voyager 1 is currently more than 23 billion kilometers from Earth. Its power supply is projected to sustain science instrument operation until approximately the mid-2030s, after which the most distant human-made object ever built will travel in permanent silence through the galaxy, unable to tell us what it finds. A spacecraft launched before the home computer existed, running on 4 watts of power, is sending back audio from beyond the solar system that is forcing physicists to rewrite their models of interstellar space, and when its transmitter finally goes quiet, that voice will be gone forever. Number 1. The roar that should not exist. In July 2006, NASA launched a balloon-borne instrument called Arcade from its Columbia Scientific Balloon Facility in Palestine, Texas. The acronym stands for Absolute Radiometer for Cosmology, Astrophysics, and Diffuse Emission, and its mission was specific: climb to an altitude of 120,000 feet, where the atmosphere thins to near vacuum, and search for the faint heat signatures left by the very first generation of stars after the Big Bang. The instrument was extraordinarily sensitive, cooled to within 2.7 degrees of absolute zero by immersion in 500 gallons of liquid helium. The team, led by Alan Kogut of NASA's Goddard Space Flight Center, spent months analyzing what came back. What they found was not what they were looking for. Instead of faint traces of ancient starlight, Arcade had detected a radio signal of staggering intensity, coming from everywhere in the sky simultaneously, with no identifiable point of origin. Kogut's description of the moment has become one of the more quietly chilling statements in modern astrophysics. The universe really threw us a curve. Instead of the faint signal we hoped to find, here was this booming noise 6 times louder than anyone had predicted. The findings were announced on January 7, 2009, at the 213th meeting of the American Astronomical Society, and 4 papers were submitted to the Astrophysical Journal. The phenomenon acquired a name: the space roar. The signal is not a blip. It is not an artifact of a single exotic object or localized anomaly. It is omnidirectional, diffuse, and continuous, a signal washing in equally from every direction across the entire observable sky. Detailed analysis eliminated every known candidate: the cosmic microwave background radiation, the echo of the Big Bang itself, could not account for it. Known radio galaxies fell catastrophically short. As team member Dale Fixon of the University of Maryland noted, to produce this signal from galaxies alone, you would need to pack them into the universe so densely there would be no space left between them. Primordial stars, galactic gas, instrumental error, all were systematically ruled out. The signal is measured to be 6 times brighter than the combined radio emission of every known source in the observable universe. That figure encompasses every galaxy mapped by every telescope ever built, every quasar cataloged across decades of observation, every star accounted for across 13.8 billion years of cosmic history. All of it together produces only 1/6 of the noise Arcade heard. Kogut himself has stated that the roar does not follow the spatial distribution of Milky Way emission, ruling out a local origin, but also that there is no convincing case for a purely extragalactic source either. As of 2025, more than 15 years after its announcement, no explanation has been confirmed. The Arcade instrument sits at Goddard Space Flight Center, and the mystery it uncovered remains exactly as unresolved as the morning it was found. Everything we know about the universe, every object detected, every structure modeled, every photon cataloged across the full span of human scientific achievement, accounts for only 1/6 of the radio noise already filling the sky above your head, and the source of the other 5/6 has never been found. If you want to see more videos like this, click the video on screen now and make sure to subscribe.